Good afternoon, everyone. Today we're going to start, I'm going to introduce our upcoming new president that will take over our new vice president that will take over the YSF, the Youth Science Forum, as we, the first intake, will have to focus or dedicate more of our time in studying for the AS levels. So let me introduce our new vice president.
Well, good afternoon, everyone. I'm sure some of you might not know me, and as our former president said, I'm Maimuna. And it seems like this is the 10th talk in the YSF stars. So I see we can just start this talk right now. So for that, let's invite Batrisha Biti Sukarneva to start the talk.
So, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. So, my name is Batrisha, and I'll be the next presenter for the YSF, and I'll be presenting about stars. I guess you guys know about stars, right? I mean, it's that blink, blink, blink thing in the sky, night sky you see, that beautiful thing that you see, and you guys gaze at it as if you're looking at your loved ones or something, right? And stars reminds me of one of the cheesy pickup lines that I like to use to my friend. You're the stars of my eyes. So without further ado, so let's begin. So just on the pointer, I guess. And let's wait for a bit. Okay. So, when I skip the objective. Okay, so yes, with technical problem here.
I try.
Yes, okay. So today, what star will be discussing about? I'll be introducing to you, give a brief intro about stars, how stars are formed, and what happens during their death. And yeah. So what are stars? Basically, stars are just bright objects found in space. Obviously, all of us knows about that.
Selamat hari dan salam sejahtera.
So do you know that the coolest stars, that is the one with the lowest temperature, is actually the red one, and the hottest one is actually the blue one. So, which is the opposite to us. Usually we indicate how hot an object is by red, and the opposite with blue. But for stars, it's the opposite. Shocking news, our stars is just an average size. Despite its big, it looks big, it's actually considered an average size. And the largest known stars is the VY Caris Majoris, which is 15,040 times the size of our Earth. That one, this one over here is our star. This is the largest known stars. You see, it's just a small dot. You can't even call it a dot. It's practically just a black thing there. So, another shocking news: the term "twinkle twinkle little star" is not true. Stars never ever twinkle. It's actually due to the fact that the light from the star, from the distant stars, enter our atmosphere and passes through a lot of our atmospheric layer, which is many layers, so it refracts and causes our eyes to see as if they are twinkling, but they are not. So stars can live up to 1 trillion years, depending on its mass. So that's what I'm going to discuss. So how stars are formed? basically, stars are formed in the region known as nebula, which is just a region of clouds and dust. This thing over here, somewhere around here, is where the formation of stars takes place. So it begins like this. You know that this is the place where clouds and dust group up. So the massive clouds and dust collapse on its own gravity, and slowly they start to stack up until at one point, they start to stack up, so that then this object becomes like a hot ball, which is very dense, and slowly the temperature starts to increase. So, and at some point, the temperature increase until it comes to a point where it can initiate a nuclear reaction. This nuclear reaction fuses the hydrogen nuclei to become a helium nuclei. This reaction releases a lot of energy. This energy is the source of energy for the stars, which is why stars are very hot. So, and it will continue, and because of the nuclear fusion, it becomes like this. This is the stable star, and it will continue to live like this for like millions and trillions of years, depending, like I said, depending on its mass. So when the stars break down, and actually the reason why stars are stable is because the nuclear reaction that is happening in their core keeps on fusing more hydrogen nuclei to become helium nuclei. So they are releasing energy. This energy has pressure. It pushes the outer layer. It pushes the outer layer of the Tesla, basically pushes outward. But at the same time, there is also the star's gravity that is pulling it, so in this case they are balanced out by the pressure that is trying to push it outwards and the gravity that is trying to pull it inwards. So at some point, when all the hydrogen has been used up, they will start. This is when the start of their death. So, there are two types. They are divided into two types. How they are depending on their mass. If their mass are like the sun, which is just the average size or even smaller, the outer layer and the hydrogen uses up. The outer layer. This outer layer here starts to collapse inwards due to the gravity that's pulling it, like I said just now. Until it starts to pile up to the core, it will reach a certain temperature at which it can undergo another nuclear fusion. But this time, instead of using hydrogen nuclei, they are using the helium nuclei. And they will continue, but because helium is bigger than hydrogen, when they fuse, they will give out a lot more energy, and so pushing the stars more and more outside, expanding it 10 times or even more than its original size, which is making it become a red giant here, you see. And slowly, and years, it will continue to be in this state until at some point it keeps on expanding and expanding. Its gravity starts to weaken, and at some point the outer layer here starts to drift up and to become a planetary nebula here. This is known to be one of the most beautiful things in the universe. And if you are lucky, if you will be able to live long or you become astronomer, you'll be able to see these wonderful things. And however, when this planetary drifts off, it leaves a very small white thing, which is known as the white dwarf. This white dwarf is actually a very, very dense and extremely hot object. It can have the size of the Earth, yet having the mass, half the mass of the Sun, which is making it a very dense object. However, for a star that's massive enough, almost like 1.5 times the mass of the sun, they will undergo a different process. Because this thing, they are able to, when it will undergo the same thing as this one, they will become a red giant. However, they will not stop fusing until hydrogen. For the average one, they will fuse until the most is oxygen. But for very heavy stars, they will fuse until up to a heavy element that could be until iron, and this causes them to have a lot of energy, expanding and expanding. However, at some point, because as you go to the heavier elements, energy are no longer produced. Instead, the energy are absorbed by the element. So slowly, there will be no longer energy that can be used up for the nuclear fusion, and so this makes the iron core collapse and followed by the rest of the layers. It collapses into the core, but however, it bounces off back and to become a supernova. That thing, the thing over there is the supernova. It grows a cap. It was a joke. It doesn't grow a cap. It doesn't even grow. It looks like that. It doesn't grow a cap. It was a joke. It was just a joke. It becomes this is a very strong explosion that can outshine the whole galaxy for briefly. And after it doesn't stop here. Depending on its mass again. If the mass is very, very massive, it can even in the middle here there will be a strong gravity pull, which eventually leads to a black hole, which is this one. This is a black in which the gravity is very, very strong to the point that no lights can escape. However, in some cases, if it's massive but not as massive as this one, then they will produce a neutron star. Like the name suggests, this is also a very dense object. In fact, it is even denser than the white dwarf. The white dwarf having the mass having the size of the Earth, but a neutron star could be only like a seed, could only be 20 kilometers across, but having the mass more than the mass of 3 times the mass of the sun, making it a very, very extremely dense object. So yeah, it ends there. So that's all, and this is basically just a summary of all of it, just to simplify. Although I didn't mention it, but actually a star which is 0.4 times the mass, which has a lower mass than the sun, will usually doesn't undergo a red giant. In fact, it will become like this and immediately go to a white dwarf. Although in some cases they do become giant, but they do not undergo this stage. They become a giant and they immediately become a white dwarf, which cools off, which after a billion of years will cool off to become a black dwarf. So that's all. So any question?
How much you use the time to present?
10 years?
Not today. To prepare.
Oh, prepare. Actually about a week or more.
Not bad. Actually, this is the oldest science, you know.
Huh? Okay.
The study of the oldest science is actually astronomy. Actually, I want to know at which state is our star now? I mean our sun.
Why?
At which state is our sun now?
Our sun is in the stable state. It has predicted age is around 10 billion years, but our sun is currently 5 billion years. So that we have enough hydrogen fuel for it to live for another 5 billion years.
Do you know that our syllabus does not have this?
Yes, I'm well aware of that.
But it is good because it will be asked in the other examination board.
Oh, okay.
Would you like to pursue this course?
No, just no.
You mentioned death of a star. So that means that once the star becomes a white dwarf, then it turns into a black dwarf, then it dies. A natural death, is that?
It's not exactly not exactly an actual, it just becomes a death. Yeah.
So the light just diminishes.
Yeah, so it's no longer become a star, like you can say. Although the black dwarf is actually just a theory, but because no black dwarf has been observed in the universe.
Any more questions?
I want to add one more thing
Okay.
because I can't really resist that. But some cases, and a star, actually in some cases, stars do not follow this kind of. They do not follow this one, the formation. In fact, when a star is so small, it has not enough temperature and not enough mass. It cannot become. It doesn't become like this. In fact, it is what we call as the brown dwarf, because in this brown dwarf, there is no nuclear fusion going on. However, it is not considered as a planet. It's because they do emit light, but it's very, very dim. That's why it's called brown dwarf. Yeah, so you just want to add that on because it's very interesting.
What about the stars that we see in the night sky?
Those stars are actually stars that's very, very far away actually. They're not that. Usually, they're not that. They're not that. They say they're not that because if they're there, usually we can't see them. From the nuclear fusion, like I had said just now, and I didn't put it here. Okay. The nuclear fusion, because in its core there is a nuclear fusion going on, where it uses its hydrogen to make the fuel. It uses this hydrogen nuclide to become He, which in this process actually it releases a lot of energy. So this energy that is released is actually the energy source for the stars. Yes. Yes. Every object has a gravity. That depends on the Speaking, I haven't researched one, but that's a very good point.
Every night, when we look at the night sky, the position of the stars differs. So, are there any explanation for that?
How can I say? It's just that stars move every day. They move. That's all. They orbit around certain day. They move. They don't stay in one place basically.
Sorry, I have a question. Can a dead star absorb energy and carry out nuclear fission again?
You mean the white dwarf?
Yeah.
Actually, yes. Actually, yes. In fact, if stars actually there are some stars which orbit two ways. How to say? Two stars orbit at the same time, in which they are involved in the binary system. If one of the stars in the binary system like I said, that die, everything goes through the process and becomes a white dwarf. At some point, even they will still orbit at the same time, at the same orbit. Then this white dwarf takes up the it will take some of the considered like material from the other next star. It takes in, and then eventually a nuclear fusion can actually take place. And eventually they will become supernova.
I have to stop you all before going. A few things that I want to tell all of you guys. We have a blog, obviously. It's this one. PTED stands for wordpress.com. You can go visit that website for updates on upcoming talks, or if you would like to recall on previous talks, it's all on this website. We also have a Facebook, Twitter, and Instagram account, all under the same name, PTED YSF. No space and no cats. We also have our first newsletter. It's very colorful, it's very nice. We're not distributing physical copies. Okay. But we do have the digital newsletter also on the blog. We just updated it recently. So if you want to check it out, it's just nothing much. It's just about the Youth Science Symposium taking place earlier this year. So everything about it is here. There's also a little about our Youth Science Forum. So you can read everything up in that blog website. I think that's all. Thank you for coming.